Imagine a world not just with liquid water, but entire oceans, miles deep, swirling beneath an icy crust in the darkest reaches of our solar system. We found dozens of them. They're called alien oceans, and they represent our single greatest chance at finding extraterrestrial life. So why, when we talk about aliens, are we always looking at little green men on dusty, dry planets? Why is nobody talking about the hidden, aquatic worlds right in our cosmic backyard? Because the truth about what might be lurking in those abyssal depths is far more unsettling than anything we could ever have imagined. To truly grasp the significance of these alien oceans, we first need to rewind a bit. For centuries, the search for life beyond Earth was largely limited to planets that looked somewhat like ours, temperate, with a breathable atmosphere and liquid water on the surface. Mars was the prime candidate, and missions like Viking in the 1970s searched for direct biological signs in its red dust. But as our understanding of planetary science evolved, so did our definition of habitable zones. Scientists began to realize that a planet didn't necessarily need to be bathed in sunlight to harbor water or even life. Gravitational forces from massive gas giants could generate enough internal heat to melt ice, creating vast subsurface oceans. The real breakthrough came with the Voyager missions in the late 1970s and the Galileo mission in the 1990s. When Galileo orbited Jupiter, it sent back astounding data about its moon Europa. Images revealed a smooth, cracked surface, eerily reminiscent of sea ice on Earth. Magnetic field readings indicated the presence of a vast, salty ocean beneath that icy shell, potentially tens of kilometers deep, dwarfing Earth's own oceans in volume. Then came Saturn's moon Enceladus, observed by the Cassini spacecraft in the early 2000s. Cassini flew directly through plumes of water vapor erupting from Enceladus's south pole, confirming an active subsurface ocean. The plumes contained not just water, but salts, silicates, and complex organic molecules, the very building blocks of life as we know it. These were not just scientific curiosities. They were game changers. The fundamental ingredients for life, liquid water, energy sources, and organic chemistry, were all present. Not on some distant exoplanet, but right here in our own cosmic neighborhood, under colossal pressure and in perpetual darkness. The implications of these discoveries are staggering. Forget the traditional habitable zone. We now have an entirely new class of potentially life-bearing worlds. But this shift in perspective brings with it a profound sense of unease. What kind of life could possibly thrive in such extreme environments? Scientists speculate about chemosynthetic ecosystems, similar to those found around hydrothermal vents in Earth's deep oceans, where organisms derive energy from chemical reactions rather than sunlight. Imagine alien versions of tube worms, monstrous squid, or bioluminescent creatures adapted to crushing pressures and eternal night. These are not organisms we can easily relate to, and their existence would challenge our most fundamental definitions of life itself. The very thought of encountering something so utterly alien, potentially intelligent, and existing in an environment so hostile to human exploration is deeply unsettling. Exploring these worlds presents an almost insurmountable challenge. Drilling through miles of solid ice, deploying submersibles into oceans we can't see, and navigating crushing pressures in frigid, dark environments is a technological nightmare. NASA's proposed Europa Clipper mission will perform detailed flybys, but a lander that can melt its way through the ice and explore the ocean itself is still decades away, if it's even feasible. The cost, the complexity, and the sheer audacity of such a mission are staggering. And then there's the ethical dilemma. What if we find something? What if we accidentally contaminate these pristine environments with Earth microbes? Or worse, what if we awaken something that should have been left undisturbed? The potential for a first contact scenario in such an alien environment raises existential questions that humanity is ill prepared to answer. Now let's fast forward to the most recent tantalizing details. The Cassini mission, before its dramatic plunge into Saturn's atmosphere, delivered even more incredible data about Enceladus. When it flew through those plumes, instruments detected molecular hydrogen, a key sign of hydrothermal activity and a potential food source for microbes. This means the ocean floor of Enceladus could be teeming with energetic chemical reactions, just like the black smokers on Earth's ocean floors that support thriving ecosystems. Furthermore, observations of Europa's surface fractures suggest potential plume activity there as well, though less frequent and harder to confirm. The discovery of complex organic compounds inside the plumes of Enceladus, including larger molecules that could form cell membranes, pointed towards a chemistry far more advanced than simple building blocks. It's not just water, it's water rich in the ingredients for life, interacting with a rocky core that provides the energy. We're talking about potentially Earth-like deep sea conditions, but existing around a gas giant, billions of miles from the sun, under a shell of ice that's twice as thick as Mount Everest is tall. The scale is almost incomprehensible. These aren't just puddles. These are titanic, global oceans, hidden from view, potentially harboring a diversity of life that could make Earth's biodiversity seem tame by comparison. The sheer antiquity of these oceans also offers food for thought. They've existed for billions of years, offering ample time for life to emerge and evolve, perhaps to levels of complexity we can only speculate about. The idea that evolution could have taken a completely different path in these lightless realms, creating utterly unique biological forms, is a source of both wonder and profound apprehension. So why the silence? Why aren't we shouting about these alien oceans from the rooftops? Perhaps it's the profound strangeness of it all. We like our aliens to be familiar, to fit into a neat, digestible narrative. The idea of microbial mats thriving at hydrothermal vents or bizarre, gelatinous creatures drifting in lightless abysses doesn't quite capture the popular imagination like a flying saucer. But more fundamentally, perhaps it's fear. Fear of the unknown, of what these discoveries might truly mean for our place in the universe. If life is abundant in such extreme environments, then it's not special. And if it's vastly different than our attempts at communication, our very understanding of intelligence might be entirely misguided. The alien oceans are waiting silently under their frozen shells. They are our greatest hope for finding life, but they also hold the potential to shatter everything we thought we knew about life itself. When will we be ready to truly look? And more importantly, when will we be ready to accept what we might find staring back from the darkness?